Hello everyone, welcome back to the channel. So in the last session, we have discussed about significant figures, that is mathematical operations carried out by using significant figures, that is addition, okay, subtraction, division and multiplication using significant figures. Well, now and further when we consider the rounding off of numbers, rounding off of, that is uncertain digits of a number. Yes, there are certain rules, as I considered the three rules to be followed during the rounding off of uncertain digits or uncertain figures in a number. Well, now in this session we are going for the next concept or the continuous part of the chapter, that is, so we are looking forward a new concept, that is a dimensional analysis. Okay, first I am going to concentrate on which chapter concept, that is dimensional analysis. Thereafter we go for law of conservation of mass. Okay, well, what do you mean this dimensional analysis? So this, the dimensional analysis is nothing but, so during calculation, say think of during calculation of anything, it is necessary to, it is necessary to necessary to convert units from one system to another. In that case, what happens? So whenever if I want to convert the units from one system to another system, we know about conversion of centimeter, say CGS system, for example CGS system, here length is expressed in terms of centimeter. Okay, length is expressed in terms of centimeter. Yes, so according to CGS system, length is expressed in terms of, okay, centimeter. If I consider MKS system, okay, MKS system, so is one more system of measurement. So according to MK system, here length is expressed in terms of meter, which means we have to convert, if I want to convert unit from CJ system to MK system, or else say we can discuss SI system, international system of measurements. Okay, SI system. So for conversion of unit from one system to another system, we have to follow again certain rules. Yes, so often while calculating, there is a need to convert, okay, need to convert what? Units from one system to another system. Yes, how to convert that? That conversion must be followed certain, okay, certain factors, or I can say certain rules. Yes, here the method used to accomplish whatever the methods or whatever the procedure followed for the conversion of unit from one system to another system is nothing but it is called a factor labeled method. Okay, factor labeled method, or it is also called unit factor method, or even you can say simply dimensional analysis. So, okay, so what is dimensional analysis? It is the method, it is the procedure, standard method or standard procedure which is followed when to convert unit from one system to another system. Okay, whatever the method we follow, it is called a dimensional analysis. Say for example, say how many seconds are there in 2 days? So what is the question here? How many seconds? How many seconds are there in 2 days? Yes, say we know the concept. We know that one day is nothing but how many hours? Say 24 hours. We know this concept. One day, ಒಂದು ದಿನ ಅಂದ್ರೆ ಎಷ್ಟು 24 ಗಂಟೆ ಅಂತ ನಮ್ಗೆ ಗೊತ್ತು, 24 hours. Further, we know that 1 hour is nothing but how many minutes? 60 minutes, right? So 1 hour is nothing but 60 minutes. Further, 1 minute is nothing but what? 60 seconds, because we have to calculate seconds here. How many seconds are there in 2 days? So what it mean? We have to convert 2 days into in terms of seconds. Those 2 days must be expressed in terms of second. That conversion is done with the help of dimensional analysis, or in another words I can say this conversion itself is a dimensional analysis. Now I have considered here days into second, as like we can convert any things, whatever the units. The conversion of unit from one system of measurement to another system of measurement is called a dimensional analysis. Well, here now we wish to convert days into seconds. How many days? 2 days into second. Yes, what is the basic data we know? Say 1 day is nothing but 24 hours, 1 hour is nothing but 60 minutes, and 1 minute is nothing but 60 seconds. Well, here now to convert, therefore converting 2 Z 2 days into second. What is that? The unit factor can be multiplied in series in one step only. Okay, all these unit factors must be multiplied here. That is 2 days into 1 day, 24. So days can be converted into, say, 2 days. Days can be converted into hours. How? 2 days can be converted into 2 into 24 hours. Further, these hours can be converted into minute. How? 2 into 24 into 60. Now it becomes minute. If multiply with the minute, it becomes minute. Further, it can be converted into second. How? 2 into 24 into 60 into 60 second. Right? So whatever the answer we get, it is the answer for what? We are going to get seconds. Say 2 days. 2 days will be converted into seconds. Same thing I am doing here. So 2 days into 24 hours. Now we get answer in terms of hours, but we need in terms of second. Further, what we are doing is multiplied. Further multiplied with the 60 minute and further multiplied with the 60 seconds. So whatever the answer we get, that answer will be in terms of seconds. So 2 into 24 into 60 into 60. Okay, well, so what is the answer here? That answer is 1,72,800 seconds, which means that 2 days are converted into second here. Whatever the method followed is called dimensional analysis. Okay, you got it? Well, so we consider now law of chemical combinations. What is the law of chemical combinations? So we know that matter exists in various forms, right? Matter exists in different forms. How it is possible? It is only because combination of elements. So whenever elements combined in a different ratio result into different forms of a matter. So when I consider the chemical classification of a matter, yes, I considered, okay, mixtures and pure substances. In mixtures again we considered homogeneous and heterogeneous, right? So how we are getting different kind of matter? It is only because of change in the combination, or I can say composition. Means whenever elements combine in a different proportions, it leads to different type of a matter. So here how they combine, which means how we are getting variety of matter, means it is only because of as elements combine in a different proportions, which results into different type of matter. It's a simple thing. Now yes, here we are getting different type of matter. It is because of combination of elements. ಅಂದ್ರೆ ನಮ್ಗೆ ಯಾಕೆ ಡಿಫ್ರೆಂಟ್ ವೆರೈಟಿ ಆಫ್ ಮ್ಯಾಟರ್ ಸಿಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಕಂಬೈಂಡ್ ಆಗ್ತಿದಾವೆ. ಹೌ? ದೇ ಆರ್ ಕಂಬೈಂಡಿಂಗ್ ಇನ್ ಎ ಡಿಫ್ರೆಂಟ್ ಪ್ರಪೋರ್ಷನ್ಸ್. ಅವು ಬೇರೆ ಬೇರೆ ರೇಷಿಯೋ ಅಲ್ಲಿ ಕಂಬೈಂಡ್ ಆಗೋ ಸಲುವಾಗಿನೇ ನಮಗೆ ಬೇರೆ ಬೇರೆ ರೀತಿಯ ವಸ್ತುಗಳು ಸಿಗ್ತಾ ಇದ್ದಾವೆ ಅಂತ ಹೇಳ್ತೀವಿ. ಎಸ್, ಹೌ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಅಂಡರ್ಸ್ಟೂಡ್? ಎಸ್, ದಟ್ ಕಾಂಬಿನೇಷನ್, okay, combination of elements can be better understood with the help of law of chemical combinations. Now ಇಲ್ಲಿ ಟೈಟಲ್ ಹೇಳ್ತಿದೀವಲ್ಲ, law of chemical combinations. Yes, that formation of different kind of matter can be better understood with the help of what? With the help of law of chemical combinations. Yes, there are, okay, the formation of compounds from elements is based on the 5 set of laws. So what are those? First one, first law is called law of conservation of mass. It is the first law. Second one, law of definite proportions, or it is also called law of constant composition. Okay. Then third one, law of multiple proportions. Okay. Then the fourth one, Gay-Lussac's law of gaseous volume, and the fifth one, Avogadro's law. So yes, here the formation of compounds from elements, it can be understood better with the help of these 5 laws. What are those? Law of conservation of mass, law of definite proportions, or it is also called law of constant proportions, and the next one, law of multiple proportions, and the fourth one, Gay-Lussac's law of gaseous volumes, and the fifth one, Avogadro's law. So the statement of these law is very important. Okay, well, try to understand the statement of these so that you can solve various numericals based on these concepts, law of chemical combinations. Well, we try to understand one by one. Well, in this session I'm going to concentrate on the first law. What is that? Law of conservation of mass. Okay, yes, We already know the meaning of a mass, right? So mass is nothing but is the quantity of matter. Quantity of matter or amount of substance present in a substance. The amount of matter present in a substance is called a mass, right? The amount of substance present in a matter is called its mass. And what about mass? Mass is a constant quantity. Mass remains constant, it doesn't change. Mass of a matter remains constant, okay, irrespective of gravity of a planet. Mass of a substance always remains same. Well, here conservation means, we know the meaning of conservation. What it is? Conservation means it is, we can say conserved, preserved, or we can say reserved. So law of conservation of mass is what it basically says is, this law was proposed. Okay, the law of conservation of mass was proposed by Antony Lavoisier. What is the name of scientist? This law was proposed by Antony Lavoisier. Yes, what is the statement for this law? So according to law of conservation of mass, what it says? Matter. Okay, matter neither can be created. Matter neither can be created or nor destroyed. What it means? Say matter neither can be created, which means matter cannot be created nor destroyed. But what we are doing? But just we are going to convert but one form of matter. Okay, one form of matter can be converted into another form, which means what the law says here, matter of the universe remains same. Okay, whatever the quantity we have, whatever the quantity of matter exists in the universe, it remains same. Matter of the universe remains same, but the quantity of matter, whatever the matter exists in the universe, it remains same. Therefore we are saying matter neither be created nor be destroyed. ಅಂದ್ರೆ ಏನಿಲ್ಲಿ ನಾವು ಮ್ಯಾಟರ್ ನ ಕ್ರಿಯೇಟ್ ಮಾಡಕ್ಕಾಗಲ್ಲ, ಅದನ್ನ ಡಿಸ್ಟ್ರಾಯ್ ಕೂಡ ಮಾಡಕ್ಕಾಗಲ್ಲ. ಯಾಕಂದ್ರೆ ಈ ಮ್ಯಾಟರ್, it it exists in different forms, right? So what we can do here, we can change only one form of a matter into another form, that's it. So what the law says? According to law of conservation of mass, mass of the universe remains constant. ಈ ಯೂನಿವರ್ಸ್ ಮಾಸ್ ಏನಿದೆಯಲ್ಲ ಅದು ಯಾವಾಗಲೂ ಸೇಮ್ ಇರುತ್ತೆ. ಆ ಮಾಸ್ ಅಲ್ಲಿ ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ. ಏನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ? In an universe, only one form of a matter will be converted into another form, but there is no change in the mass. Mass of the universe remains same. Or simply in another way, how we are saying, matter neither be created or neither can be created nor destroyed. So one form of matter, what is possible? One form of matter can be converted into another form. So this law was proposed by one of the most important law, which is law was proposed by Antony Lavoisier. Okay. Now, yes, it can be better understood with an example. Say, think of formation of a carbon dioxide. Okay, formation of carbon dioxide. So if I consider formation of carbon dioxide, say carbon dioxide I am saying, so what are the elements would be? There will be carbon and oxygen. So when carbon combines with oxygen, resultant will be carbon dioxide. So I have written here, carbon plus oxygen gives rise to carbon dioxide. Well here, so what are the elements required? Yes, we considered carbon and oxygen, right? So now, if I consider the chemical reaction, what would be the chemical reaction? Say carbon means C, oxygen means, so we know that oxygen exists as a diatomic molecule. So O2, C plus O2, carbon dioxide. So answer, that result will be CO2. Product formed will is CO2. So C plus O2, CO2 is a chemical reaction. Now, if I consider atomic weight of carbon, so what is atomic weight? Atomic weight of carbon is 12. So 12 gram of carbon. See here 1 mole 1 mole of carbon is there in an equation, so I can consider 12 gram of carbon plus, say, what is the atomic weight of oxygen? Atomic weight of oxygen is 16, right? So 16, but here it is a molecule, right? Diatomic molecule. Then how many, what is the weight of two oxygen atoms here? So 16 plus 16, that is 32 gram. So say 12 gram of carbon plus 32 gram of oxygen, they are combining. Plus anta ಏನು ಹೇಳ್ತೀವಿ ನಾವು, they are combining, they are reacting. 12 gram of carbon reacts with 32 gram of oxygen, well, gives rise to what? Carbon dioxide. Then here, what is the molecular weight of carbon dioxide? C plus O2, right? C plus O2, one carbon and two oxygen atoms. So what is here? One carbon 12 gram, so one carbon 12 plus two oxygen 16 plus 16. Say 16 plus 16 32, 32 plus 12 44 gram. Well, so CO2, what is its molecular weight? Molecular weight is 44 gram, right? So, well, now if we compare, during a reaction, what happened? Carbon is one form of matter, right? Carbon is a one form of matter. It combines with the oxygen. Oxygen is another type of matter. Both exist in the nature, say carbon reacts with oxygen, gives rise to carbon dioxide. Yes, it is a one more kind of matter, different type of matter. Say carbon, oxygen and carbon dioxide all are a different kind of matter, right? Well, here what we are analyzing, so one form of matter, carbon and oxygen, they are get converted into what form? They are converted into carbon dioxide, a different form of matter. It also exists in a nature itself, right? So what happened here? Just one form of matter is converted into another form. Whether they go out of the universe, no, all exist in the universe itself. But what happened? One form of matter is converted into another form. That's it. Okay. Now during this conversion, say it is a chemical reaction. During this chemical conversion, when you look at the mass, so what are the total mass of reactants? So reactant means carbon plus oxygen. So 12 gram of carbon reacts with the 32 gram of 32 gram of oxygen. So 12 plus 32, how much? It is a 44 gram, right? 44 gram of reactants is the total mass of reactants. Well, similarly, if I consider total mass of product formed, how much product formed here? 44 gram of carbon dioxide formed. Means when you look at the mass of reactant and mass of product, both are same, right? Say what we are analyzing, mass of reactants is equal to mass of product. A chemical reaction which takes place, reaction happened here, but what about mass? Mass remains same, there is no change in the mass, right? What it mean? Yes, during a chemical reaction mass remains same, but what happened? One form of matter is converted into another form. So here what I can say, mass neither be created nor be destroyed. Yes or no? Mass neither be created, we are not getting any extra mass here, or else not destroyed, which means we are not getting less mass at the end of a reaction. Same, mass remains constant. What is the law says? So here, according to law of conservation of mass, what it says, mass neither can be created nor destroyed, but one form of mass can be converted into another form. So it can be better understood with an example, right? So if I consider formation of carbon dioxide, total mass of reactant is 44 gram and total mass of product is also 44 gram. So what I can say here, so according to law of conservation of mass, so mass can neither be created nor destroyed. Okay, please remember this. Well, now if we consider one more example for this, say for example 10 gram of calcium carbonate, okay, 10 gram of calcium carbonate on heating gave 4.4 gram of carbon dioxide and 5.6 gram of calcium oxide. Show that these observations are in agreement with the law of conservation of mass. So what is the observation? They said calcium carbonate on thermal decomposition gives carbon dioxide and calcium oxide. What they are saying, when 10 gram of calcium carbonate is heated, gave 4.4 gram of carbon dioxide and 5.6 gram of calcium oxide. So simply we can say here, say reaction equation if I consider, as I said, calcium carbonate on thermal decomposition, on heating, what happens? It decomposes to give calcium oxide and carbon dioxide. So mass of the calcium carbonate, how much mass? 10 gram. So is the total mass of, okay, reactant. Mass of product formed. The same mass of product means mass of carbon dioxide plus mass of calcium oxide. So what are the mass here? Mass of carbon dioxide formed is 4.4 gram and that of calcium oxide quicklime it is 5.6 gram. So how much it is? Again 10 gram. So what I can say here? So mass of again what we are observing here, mass of reactants is equal to total mass of reactants is equal to total mass of product. Yes or no? Here also we can analyze this. Therefore, what I can say, yes, it also going to agree the law of conservation of mass. Okay. Well, so please go through the statement, and that example is very important. Okay. Well, so now with this, I'm going to conclude about this session. Again, in the next session, we go for other concept. Okay, thank you. Be safe.